Bismillahirrahmanirrahim. Assalamu alaikum. Today we are going to start with the lecture number 19, and in this lecture we will discuss about the input output and conditional jump instructions in assembly language. So in lecture number 18 we discussed all of those instructions like input output instructions and the jump instructions. Today we will review and then we will program them. We will program all of those instructions and see how they behave in assembly language. Along with those topics, we also discuss about the program components. And those program components include the .386 directives and model directives and so on, how we can use them, what are the sizes, like in model we can use standard call, or we can use flat, tiny and so on, like 32-bit directives and also 32-bit options and 16-bit options. So here we will review all of those topics that we discuss within meantime, and we will continue with the programming logic, how we can implement them in assembly language. So IO instructions, we discuss about the stdin instruction or the procedure which is defined in the MASM32 library file. So the syntax is like this one. Here you can see the standard stdin, and then we have the word. So this is the buffer which actually stdin is used to receive data from the standard input device, which is a keyboard. So here we define the buffer or the memory area where we store all the information or all the data which we receive from keyboard. So this should be the address of that area, starting address, and here is the length. So total length that we can receive or we want to receive. Description is that standard in or stdin receive text input from the console and places it in the buffer required as a parameter. So this buffer is used as a parameter. This function terminates when we press enter key. And here is the example. Here you can see this is the example. And in this example we have the invoke command is used to call the functions. This is the call the procedure. So here is the stdin procedure. First parameter is the there is no comma here. So there is address buffer, address of this area or buffer area. This is the variable name which is of byte size, but byte in multiple byte size, and the size of this one which we receive is 100 bytes. So the parameters, the buffer, this buffer to receive the text input from the console, and this is the length of the buffer as we discussed. Similarly, on the other hand, there is another directive or another procedure inside the MASM32 lib and include file, which displays the information which is stored inside the buffer or somewhere inside the memory. You can see here that description that stdout will display 0 terminated string. Whatsoever the string that we are going to print, it should be 0 terminated, means in the end there should be 0 and so on, whatsoever we are going to print. And here is example, we write invoke stdout and then the address of this. For example, message 1 is the area where a string is being stored, so we want to print that on the screen. Standard output device is our monitor or a screen where information will be displayed or sent. And this is the text. This parameter is a 0 terminated string, so there should be 0 at the end, and this will not return any value. This procedure will not return any value. This was the example. Here you can see we have defined two messages or two variables. These variables of size byte, and we have the type where the information inside this one is type your name, and then at the end there is 0. So 0 is part of this message 1, and then next one is your name is something like this one. This is the undefined, we did not assign any value, so you can define those that one in the under this directive dot data and question mark, even though you can define it here and so on. So here is the buffer area or the area where you will receive some data from the keyboard and store here. This has the 100 byte size, and the value is not defined here. Inside the code we call stdout, invoke stdout, address of message 1, invoke std in, so here it will print the message 1, whatsoever the message 1 is, type your name, then invoke std out, address message 1 will print this message. Then what will happen, it will wait for the keyboard to receive 100 characters, or it will be terminated until and unless you are not going to press enter key. Whatsoever data you will enter, it will be stored in this area, the buffer area, or in this message under this reserved words, or under this variable. And what will happen next we are going to print what is inside the message 2. So message 2 has your name is something like this one, and std out the buffer, we are going to print whatsoever you received from the buffer from the keyboard, because whatsoever you received from the keyboard, you typed anything, it was stored inside the buffer. Now we want to print this one. So the next one is, this one is again we are going to receive some data. So here, even though if you enter data, it doesn't matter, it will again replace the previous buffer. Here we included this statement so that program just wait for your enter key to terminate. Even though if you type, it will not terminate until and unless you don't press enter key. So the output will be like type your name. So it will be like type your name and something or whatsoever. For example, if I type A, B, C and so on whatsoever, then it will again print your name is ABC and so on. So it will wait for you to press enter, then it will terminate the program and so on. After that, we discuss about the jump instruction. So conditional jump, there are different types of different categories of conditional jumps. Here, jump below, jump compare. So jump to a label when the carry flag is based on the flags, based on the conditions like the comparisons like less than or greater than and so on, based on the unsigned comparison and signed comparison and so on. So here you can see jump below and jump carry, jump equal or jump 0. So they are equivalent statements or instructions inside the jump. Jump when sign flag, jump not equal or jump not 0, jump when ECX variable is equal 0 and so on, jump when ECX is 0 and so on. So here there are some jump ranges in 386. There are some jump ranges in IO 32 processors. That means prior to 386 you can jump only to 127 minus 128 to 127 because there are 16-bit architecture and we use segments, and within the segment you can jump between this area and so on. But here in Intel architecture, 32-bit architecture, you can jump anywhere inside the memory and so on. Here's the list of all those jump instructions where the jump you can jump based on the flags: jump 0, jump not 0, jump C, jump not C, and not carry. Jump carry when carry flag is set, when carry set is not set, so on. That similarly here, jump when overflow, no overflow, not overflow, jump sign, not sign, jump parity and not parity. Then we have the jump. This is the jumps based on equality. So jump equal when the two operators they are equal, which we are using before this jump instruction. Either we use test or we use comparison. So jump not equal when the two operators are not equal. Jump CX, CX is 16-bit register. When contents of CX registers are 0, then jump will happen. This is the opposite of this one. This instruction J jump when ECX is equal 0, so 32-bit same register of CX register of 32-bit size when its contents are 0. Then unsigned jump. Here are the unsigned comparisons. So jump will happen based on unsigned comparison. So we have jump A above, jump not below or equal. They both are same. Jump above or equal or jump not below. Jump below or jump not above or equal, and jump below or equal or jump not above, and so on. So here they compare two operands before these instructions. Before these jump instructions, we compare two operands. and we will see either they are equal, not equal, less than, means they are greater than, less than, greater than or less than, whatsoever we can call them. There are different ones. So jump above means when left operand is greater than the right operand. Not below or equal is similar to jump above. Similarly, jump above or equal means when the left operand is equal or greater than, and so on. So it is a complete list. The third category was in the same category we have the signed comparison. So similarly to jump above, and unsigned has the same one when we compare two signed numbers or signed variables or signed registers values, signed values inside the registers. So we use jump greater than if the left operand is greater than the right operand, and so on. Jump not less than or equal, so these two are same. Similarly, jump greater than, equal, and so on. Jump not less than, and this is the complete list. Now here, this lecture, we will implement all those IO instructions, and not all the jump instruction, but few of them, to show you that how they work and how you can design the logic. So let's enjoy the assembly. So now we are going to start with the assembly language, and we will try to implement all those examples in Visual Studio, Microsoft Assembly. So we open a new project, and this is the Windows 32 console application, and it should be stored in the lecture number 19. And here is we stored lecture number 19, and it's example 001 underscore IO. Okay, so here we are going to store, and this should be the empty project. The project properties, you can set the build customization, MASM32 targets, and so on. We add new item. For example, new item will be saved as a lecture 19 example 001 IO dot ASM. Okay, so we will set the properties here. Include path, the C drive, MASM32, include, and so on. Now this is the skeleton program, you can see here. So .386 directive, we are using the 386 instruction set, which is the most compatible, and it's compatible means all the new architectures which we have right now, they support this 386 architecture, and this one is 32-bit, and nowadays most of the computers are 32, and even there are 64, but right now we are programming for the 32-bit architecture. Memory model is a flat, and the cache map is on. So here we have the include files. The best way is to use C drive, the whole complete path, MASM32 / include, and these files are actually placed on C drive. The subdirectory name is MASM32 include, and so on. So, and for the lib, the path is different. Actually, it is MASM32 and lib. So we will change here lib, and the same we will copy here for the kernel lib and the MASM32 lib. So all these are the include file. This one is for Windows when we are programming for the Windows, and then kernel 32 is for when we transfer control to the kernel, and all the instructions and the directives which are related to the kernel, like the actual operating system, like transferring control to the kernel and so on. Then we have the MASM32. These are like IO instructions and other instructions that we are using. They will be used for the this MASM32 lib has all the procedures which we are using right now here. Now for example, we want to have message 1 and is the byte, and the name inside this one is, for example, hello assembly CSC221 and comma 0. So this is the 0 terminated. And next one, what we are doing here is the we want to print this one, so we use invoke. The same one, invoke is also used to call the procedures with parameters. So after the procedure there should be comma. So std out comma, the parameters start with the where you need only address message 1. So here message 1 is an array of type byte. Our message 1 holds the string or array of characters or complete string. So here total length of this message 1 is starting from H character to all these spaces, including spaces and so on, and also including this 0. Now we want to print this one. Just we save, we build the project. So this is build is successful. Now what we are going to do, we just run this one. It's a bit slow, so I want to make it like squeeze so you can see this console. So actually whatsoever we are using as an stdio or stdin, their output will be displayed in this console window. So here you can see our program has the startup point is here, so it will execute this one. For example, if I press step F10 again, so here you can see here at this point here hello assembly CSC221 and so on. So this is the message that we wanted to print, so it has already printed this message. Now this is only when you print something. For example, if we need some, so next instruction is to execute, so we just execute, complete the execution of this program. Now if we want to receive some data from the keyboard, so for example there was example hello okay, and then we have input 1 is byte and 100 duplicate is, we're not sure. So for input, to receive input, we will use invoke stdin comma. Now for the stdin we need the address like input 1, where our whatsoever will receive, it will be stored inside this input 1, and the size, for example 100 bytes we want to receive from here. And then if we receive whatsoever we will receive input 1, we want to print, for example invoke std out comma address. We can directly print this one, or maybe we can write something like here. For example, if I write message 2 is byte, and then okay, nice to meet you, and so on. So it will just print this message and then your name, whatsoever you will type. Okay, so message 2 will be printed, and then std out for the input that you receive. Now we are going to build again, and we just run. So when we run, you will see here our program is running. Actually this one is a full screen, so we can make it small, and hopefully you are watching this both screens. Now in this screen you will see the output. This is the console command prompt window where you will see everything that we are printing here. If I type F10, so it will print this message, hello, what is your name? And now when I press F10, then it will go here and I ask me the name. For example, it was, my name is, for example, Safdar, and again it will print the second message. When I entered, it returned back to the program execution, nice to meet you, Safdar, and then exit from program. So now what we are going to do here, actually we are executing our main program in steps. So instead of doing that one, we can continuously execute our program. For example, again I call invoke stdin comma input 1. So here what will happen, it will just wait for the intro key, and I just build this one and I will show you what will happen. So okay, so there's few arguments. So invoke stdin, so okay, we missed the total size. For example, size is 100, so we again build this save and we build this one solution. It is successful. Now instead of running our program in steps, what I will do, I will start debugging or continuously. So this is the what's your name. If I type like CSC221, so it will say nice to meet you, CSC221. So it is executing the whole program continuously, and when I press enter, it will return back. So even instead of pressing enter, I could press anything, any key, but it will never enter until unless you don't press enter key. So here you saw that we can print out any message, we can print out any information on the screen, and we can receive any information from the screen and we can store it inside our program. Now what we are going to do, we are going to test some other examples, like for the jumps and so on. Then we will see how we can develop our logic. For example, here we will test some. I just save this program. Before saving this one, I just copy this skeleton. Okay, I just copied this one. I just save this one. I close all the solutions, close everything, open a new project. Example, this is the 002. Okay, this is empty project. Its properties, lecture number 19, and we have the example 002 2.asm. So this is our file. We can paste whatsoever we did in our previous program. Okay. Now in this program, what we are going to do, we will test all the jump instructions that we did. So in these jump instructions, what we will do, we will test few of them, and then we will create a program logic that you will see how we can. First of all, we will try to have some instructions to test either the jump is going to be performed or not. For example, if we want to use compare statement or CMP, compare or before compare move EAX, 10 move EBX comma 20 and so on. And if we compare EAX comma EBX, and if I say jump, JMP, simple jump is the unconditional jump. So if we jump above, if EAX is greater than EBX, then it will jump to L1 or label LABL1. And if we want to print something, message 1 is the byte message, and we say EAX is greater, comma 0, and message 2 is the byte EAX is less or smaller. Okay, so there are two messages, or two things are, so here is the label 1, which we want to, if EAX is greater, then it will go to label 1 LABL1, and here what we are doing here, we are just going to invoke std out, comma, and we have the address of the message 1, and then it will come to the end of the program. In case if it is not like EAX is not greater than EBX, then we can write here invoke message 2, and this is the unconditional jump, JMP label 2, for example. So label 2 is here to terminate the program. Okay, so we will skip this statement. Instead of printing this statement, we will skip from here to label 2. So I can write LABL2 colon, so this is second label. So this is very simple program. What we are going to do here, we have some value in EAX, and then we have assigned some value in EBX and so on. Then we are going to compare these two values, EAX and EBX. We are going to jump based on this comparison. So if EAX is above or greater than EBX, then it will jump to the label 1. Here it will print this message, invoke std out address of the message 1, and then it will exit. Okay, otherwise the next condition is possible, that if EAX is less than or equal to EBX, then this jump will not be performed, and what will happen, it will print this message 2 that EAX is smaller or EAX is equal to 0, and then it will jump to label 2. So we will skip this statement and we will directly execute this statement and so on. So here, for example, if I just build this project and just see was there any error or not. So there is no error, so build is successful. Now we just save this one and just here I think it's better we just use some statements before going to we say input in1 is byte, so we don't need to run it in step by step. So we say 10 duplicate. Okay, so here we say std invoke std in comma address of in1 comma 10. So in1 is the name and 10 is the total size that we will receive. So here, okay, now the logic is very simple. We don't need to make it more complex right now. So it's successful. I want to run this program, so debug. Here you can see the output is EAX is smaller. EAX is smaller. You can see if I don't know how we can make it like so if we can maximize now so the properties, we can have the font size should be 24 for example, or maybe bold fonts. Okay, so Consolas and Lucida console, so 24 is I think good, boldface. So EAX, now I think it should be easier to see this one. So now it displays EAX is smaller, and if I enter, it will exit from the program. So this is jump above. For example, if I use jump below or jump below, so here jump below means if EAX or EBI, the same logic can be happen with the if I say jump greater, but in this jump greater means if EAX is greater than EBX. This one is if we have the signed one. So in case of signed one, we use jump greater if EAX is greater than EBX. So this will be used in jump greater. The output will be same. If I debug or build, it's okay, and if I run this one, so EAX is smaller. So this is the same thing compared to the jump A. It's similar, but the difference is we have the if these values are considered as the signed values and so on. Okay, so even though if we use a constant value here, if I use 10 for example, and we are using jump greater or jump above, so EAX has a 10, EAX has the value 10, and we are going to compare with the constant value 10. Now what will happen if I run this compile, debug, and run this program? In this case also it will display the same thing, EAX is smaller. For example, if I write jump above or equal, okay, above or equal, and I build, so in this case what will happen, it will not print it will print, for example, this message. So above or equal means if EAX is greater than or equal to 10, if any of the condition satisfies, then it will print this message too. For example, if I write above greater or equal, for example, here so message 1 is smaller because here I have changed the condition. If jump A above or equal, if it is EX is greater than this one, so message 1 be here the greater than or equal, and this should remain same. Otherwise we have to change the complete program logic. So here jump above or equal to label 1, so it will print here this message. The message is message number 1, that EX is greater or equal, and in case if it is not greater than equal, then it will print invoke stdout address message 2, which is that EAX is smaller, and so on. So for example, if I compile this one or build this one, and then if I run this one, so EAX is greater or equal. So if I use this one, or in case of above or equal, if I want to use here greater or equal, so they are almost similar, only greater than or equal is used for the sign extension, the sign numbers, not the sign extension here. they have the same, so EX is greater or equal. Jump 0, for example. If I compare these EAX and 10, for example, then if they are equal, then the 0 flag, here you can see, if we run this, oh sorry, I think we have to compile this one, and because we have changed this logic and we have to build this solution again. So I just terminate this one, I build, so 0 failed, so 1 is updated, so I just, it's okay, recheck, 1 is successful, update is also is clear, means our previous solution was correct and we have just updated that one. Now what we are going to do here is we are trying to run this one in step-by-step manner, and we want to see the registers also. We want to see these registers. Here you can see all these registers. Okay, this is good. Now we just run in step-by-step. So first is EX has the value 10, so 10 in hexadecimal is A. Then EBX has 20, okay, so 20 is 1/4 in hexadecimal. So we compare. So now here I think flags should be displayed here, and we could see these flags. So 0 flag is already 1, for example. If we compare them, then 0 flag will be similar, and same 0 flag is 1, so there will be no effect. In case if 0 flag is 1, then what will happen? Jump 0 to label 1, so it will jump to the label 1 and it will print the message 1 whatsoever. So greater or equal, you can see. So when two values are equal and if we compare, then definitely the 0 flag will be high or on. If it is less, then you can see what will happen. I just terminated this one, and EAX is less, it's like 9, for example, and I want to print, I want to run this program and see. So here we have all these flags, assign the value and compare EAX and 9. So if you see all these, so 0 flag is 0, 0 flag is 0, it means, and the other flag is, carry flag is also 0, and so on. So what will happen then, 9 is EX is less than, so it will not jump because 0 flag is reset, it will not jump, and it will invoke that EX is smaller, and so on. Now the next thing is, in case if it is larger, EX is greater than this one, sorry, here the EX is greater, for example EX is smaller, like we use 11 here. In previous example, EX was greater than this one, larger than this one. So if now we are using this one, EX is less than 11, and definitely it is, then we will see what will happen. We will see that, just see the, so EX and EBX has been assigned the values. If we compare, so carry flag is also set, and carry flag is set, and the 0 flag is 0, and so on. So carry flag and auxiliary carry, they are 1 1, they are set. And if we use jump carry or jump parity and so on, so we can use, so 0 is not set because they are not equal, it is only set when they are equal. So it will say that EX is smaller, and so on. It will complete the execution and so on. We just complete this one, and now if I use jump carry, so it will jump when carry flag is set. Carry flag is set, and it will jump to somewhere. I think we have to jump because carry is set when EAX is smaller than this value. So we have to print the message number 2. So we have to jump to the message number, we have to print message number 2. And then I think we just change the names here, so 1 and this one is 2. Okay, we just build and run this one. So here you can see when we compare, so carry flag is 1, so it will print out the message EX is smaller, and so on. And if we just continue, so this is again starting, so no problem. Even we have used the jump carry, jump 0. Jump not 0 is almost similar with, in this case, because carry flag is set when EX is less than the comparison value, and not 0 means when the 0 flag is not set. If I just write build this solution, and if I run this one, so here you can see 0 flag is not set, so this condition label 1 will be executed, message 1 will be printed, so EX is smaller. So message 1, here you can see the message 1, the value in message 1 is EX is smaller, and so on. So you can use any of these jump instruction based on these conditions and so on. Now we are going to move and we will see what else we can do with all these instructions. Now, for example, if we have EX and EBX, both are like 10 and 20, and we want to have the other logic. For example, if something is greater than the other thing that you saw, you can implement that logic. Now what I will do, I will write one program where we will use some logic to print out something on this screen. For example, we want to have the I want to make, so file, we just save as the lecture, example 2, so I want to use it example 3.asm. so this is example 3.asm, and in this one what logic we are going to develop. For example, I want to print out whole complete series, like from 0 to any number which we enter or which we just provide. How we can do that one? I want to use jump and also these input and output instructions. Now how we can do that one? First of all, we will have to write the logic, message 1, and message 2. For example, we will write something here. Okay. Series, printing, and so on. Okay, so we will omit this one. Right now we're not sure what we will write here, and then we are going to start with our logic. For example, invoke stdin, or first of all std out, the address of the message 1, so we will print this one, save. Okay, so exit process should be there. Now we want to print a complete series. Now how we can print complete series? For example, we are starting with the move ebx comma 0. Okay, so ebx is equal to 0, and what we are going to do is that we are going to print from 0 to some value, and we are going to have the value lp1. This is the label which we will use for the loop. Now here you can use any logic. For example, if I use invoke, now here we will discuss few functions that we will use inside the printing. What we are going to use here, for example, if I want to print something and it is inside the register, then I cannot directly print the register value because we need something in we need addresses address inside the memory, so we can print out that buffer area. So we have something inside the register. We have to convert this data or transfer this data and convert into the register and so on. So this is a double word. This is double word, and we have to use some functions or some directives or some instructions to convert this double word into the ASCII. So we have one instruction called the DW, double word to A, double word A, EBX, comma, out1, for example. I want to write its name is out1. Okay, so what I am doing here is that I am going to write converting what's inside the EBX, whatsoever is inside the EBX. I want to convert it into the ASCII and put it inside the out1 string area. Next, so I will do what's about, for example, I want to invoke std out, comma, is the address of the out1, and then the next one is I want to increment EBX, then compare EBX, comma 10. So we want to compare that, compare for some amount or some number. Jump where? Jump when not 0. If they are equal, it means if they are less than or greater than whatsoever, we can jump below. We can use jump below, for example, to LP1, for example, jump LP1. Okay, so it will jump there and it will return back. So here, exit process. Now just see this output. We will modify some of this output and so on. So we are not using message 2 right now. It's as it is here, and we just build. Okay, so label 1 is not defined, so here we are using, so we just close this one. We don't need this one right now. So we just build the solution. Here we are using again the label 1. So okay, this is the complete program. I think we have to save. We have to remove this one. Remove right now. We have to close this one, add the new component, new item is the lecture 19 example 003.asm. okay, it already exists, so we can have the we don't want CPP, we want to have 4.asm. so we just save this one, save the properties. You can check here. Include path is the C drive, MASM32 on the include. Okay, just try to build this one. Successful. So we just run this one. Here you can see first is invoke. So if we just invoke this one, message, but I think the message is printed here. CD is printing, and you can see the cursor here at this point is blinking. I want to make it here, so it's blinking there. Okay, here you can see it is blinking here. So next step is move EBX is equal to 0 and the invoke DW EBX. Okay, so there's access violation. Okay, we did not write here the address, so there's one error. We want to remove this error, like we have to write the address where we want to save. So we cannot use this one, we can use the address. Successful. We run again, and here you will see the output. I want to make it here. Okay, so EBX is equal to 0, so it has been transferred. So EBX has been saved to the out1. So we are writing, so here you can see printing 0 is here, then it will decrement, compare and jump print. So you can see the series is being printed 1 2 3 4 5 6 7 8 9 and end, and the end. So I just pressed multiple times so you can see this one, otherwise. Okay, so I think it's better we just write something here about the out2. Out2 is byte type, and there are 10 bytes, and duplicate is, we don't know. Okay, now we just use here, before exiting the program, we just say invoke stdin comma the address of out2 comma 10. So we don't need to run it in step by step, we can run it directly out2. Okay, save and build the solution and run this one. So you can see 0 1 2 3 4 5 6 7 8 9, and it is waiting for my enter. When I press enter, it will exit. Now we don't want to print it like this one, like in the row. We want to print it in like 1 0 1 2 3 and so on, the complete logic from its top to bottom. Now what we need to do here, we know that when we print something, first of all we know that the 13 is the line feed, therefore enter, carriage return and so on. So 13, and then we have the code 10, for example 10, carriage return and line feed and so on. If you see all these in ASCII table, 13 and 10, you will find them for the line feed and carriage return. So it will print, and then it will come to the next line. Just compare. For example, if we see the output, okay, I want to just run this one. So you can see series printing, and then it has come here and it is printing again 0 1 2 3 up to 9. For example, what I want to do here is I want to print them 0 and then come to the next line and next line and next line and so on. So what I will do here, if I just press enter here, I want to define message 2, 13, 10 and 0. After printing this one, I want to print invoke std out comma address out2. Sorry, the message 2, not out2 but the message 2. Message 2. So this is the message 2 which I want to print, and we just build the solution and we run it. So you can see 0 1 2 3 4 5 6 7 8 9 and so on. So this is the it is going to convert whatsoever inside the EBX into the, so double word is converted to ASCII, and whatsoever is in EBX, it is double word. It is either in the data whatsoever we have is being converted into the ASCII not in the integer, or not in hexadecimal but in integer format. For example, if I want to print in, for example, 13, from 0 to 13, then what will happen? You can see here, if I want to print them from 0 to 13, so if you will see here, So it is printing from not from 0 to less than 13, so it is 0 to 12. It's 0 to 12 if I press enter. So we are here. So you saw that even though in EBX data is in hexadecimal format, but it is converting from hexadecimal towards the into the integer, and the format like the integer format, whatsoever the hexadecimal value is in here, or maybe this value is integer value. DW or double word to A or ASCII converts them into the format like integer format, and that is saved inside out1 and so on. And now this is double word to A and so on. Now what we are going to do, so this is jump below and equal. So now you will see our program's output. If I just run this program, below or equal, so you can see from 0 to 13, this is the output. And I can use jump 0 or jump not 0, for example, J and Z. Jump not 0, it will jump until and unless they become equal. For example, just write and compile and see, experiment, do some experiments and see what's the output. From 0 to 12. Why it is from 0 to 12? Because when EBX, we increment EBX, so it has printed 12, and when we increment up to 13, so we compare, and after comparison, when they are equal, 0 flag will be set and so on. So if 0 flag is set, it will not jump to the LP1, it will return back here and exit from the process and so on. So you can use any jump instruction based on your choice, whatsoever the choice logic you want to use and so on. So here is the program where we have used these input and output statements. We have used one function, is DW double word to ASCII. You can see information about this double word to ASCII inside the MASM32 help files, the library help files and so on. Now what we are going to do next is, for example, if we receive two integers or two values, we want to use them to sum or to perform some addition and so on. So here we have the message 1, enter value 1, so this is comma 0, and this is enter value 2. Okay, so we need two values. We want to make our program more interactive, and we want to perform addition and some other operations inside our programs. Okay, and these two values will be saved inside, for example, val1. So, and then we have val2, and we have out1. So we want to save this one, and I think it's better to we don't want to save. Okay, so what we need to do, we do not need all this logic. We just remove this one. So message 1 is print this message 1, and then print the message 2, and so on whatsoever. So message 1 is enter val1, and we write invoke std out, comma we need to get the input std in, comma address. Now whatsoever the value you will enter, for example, if I write address val1 comma 10, so it will be stored inside the val1. Now val1 is nothing but a string, or it can hold the characters, maximum 10 characters. And also if I write the same thing here, control, we just copy this one and message 2 and val2. Okay, so now we have got these two values inside this val1 and val2. We have printed two messages and so on. Now what is the next that we can do is we want to receive information in these two. Now first thing, when we press enter, this enter is carriage return and line feed, the CR or LF, or that they are represented as CR and LF. So that will become part of these two val1 and also val2, because when we press enter, that will become as two characters. They will be saved inside val1 and same inside the val2. So now first I will save this one, I will run, and then I will show you what is going to happen here, or what is happening here. So out1, we have removed out1. So if I just compile or build this program, so I run this program. So first interval 1 2 3, for example, if I enter 1 2 1 or 1 2 2, if I enter, so I'm going to press enter 2 times when I have typed only 3 characters and with enter, and then next 3 characters are 3 numbers whatsoever, because these numbers are stored inside the val1 and val2. They will be treated as characters. And also enter is part of this 10 size of this val1 and val2 of 10 characters. So now what will happen, what we want to do here, we want to first strip or remove those the characters which have been added when we press enter key. So there is one command we can write, invoke. The command is strip CR or strip line feed. Strip line feed, from where we want to strip line feed, address val1, and invoke, sorry, it's not strip, it's strip line feed from address val2. So we have removed those characters which have been added by pressing enter. Okay, so we have removed those one, and now what we want to do, now these 1 2 3 or whatsoever the value you are going to enter in val1 and val2, that is as a character. Either if I press 122 230 whatsoever, they are not numbers, they are characters. Now what we have to do, we want to convert them into the number, the same equivalent number. If I press 122, I want to convert this 122 into 122 in decimal. So we have the directive or the instruction that is called the, if I write invoke the 8DW, this is the opposite of the previous instruction. It is called the ASCII to double word, and this one ASCII to double word from where? From if I write number E address of val1. So when I convert, or when I execute 8DW address val1, what will happen? Whatsoever the value is inside val1, it will be converted from ASCII to integer or the double word value, and it will be stored inside the A. It will be stored inside EAX register or EX register. So I want to write two things here. If I say number 1 is the double word undefined data, number 2 is the double word undefined data, and TTL or total 1 is the double word, and we don't know the value, for example. So why I am doing this one, I will show you, because when we are going to invoke this, when we are executing invoke instruction, EAX register is also being used. So the result will be transferred inside the EAX, but if I use another invoke instruction, what will happen? Whatsoever the value is inside EAX, it will be replaced. So what I want to do, I want to move number 1 comma EAX. So I want to save this one, number 1 to EAX. Similarly, I want to strip. I have stripped these two, and I want to save them into the, so I want to save them into the number 1 and val2 into number 2, val2 into number 2. Then if I want to perform addition or subtraction whatsoever, I can perform. First of all, I want to see the total. So how can I perform total? For example, if I say add, or if I say move TTL, move EAX, comma number 1, then add EAX, comma number 2. So we have to total in EAX, and if I say move TTL1, comma EAX, so this is the total, and now I want to print this total. How I can print this total? I want to say out1. This is out1, so if I say the total should be inside the out1, so I want to convert this total into the sum format. How can I convert this one? So convert is inside the EAX. So instead of writing here, if I directly convert it, so if I convert like invoke DW to A, DW to A, double word to ASCII, and from where? From EAX to out1, to address of the out1, not out1 directly, and the spelling is wrong here. Invoke std out, comma address of out1. Okay, this is very simple right now. So we are going to perform addition and so on. What I want to do, I want to build and see, maybe we have made some mistakes. No. Okay, I want to run. Let's see. 1 2 1 2, total is 24. Total is 24. So this one is in decimal, not in hexadecimal. The total is in decimal, not in hexadecimal. And 1 2, what we enter is also in the, for example, 123. I want to add some other values. Is the 123, 124, 247. Okay, just try another one so that to make sure. So if I say 99 plus 1 1, so it should be 9 plus 1 should be A in hexadecimal, and 9 plus 1 should be A, so it should be, but it is here, you can see it is 110. It means everything whatsoever we are using here is being treated as an integer. We can use as hexadecimal addition also. There are different ways to perform hexadecimal addition. So for example, the same value, if I want to print in hexadecimal, what I have to do, there is another one. So if I say so here is the, if I say DW2 hex, DW2 hex is a function which convert the value in EAX inside here in hexadecimal, and we are going to print this one, and then we will see. But I think it's better that we use a variable, or better is to push value of EAX, because here value of EAX will be in the out, and this DW2A and std out will change the values of EAX, and here we can use pop EAX. So we can use stx also. So we will get the original value before invoking these two instructions. So you can see, we can, this is too handy. We can push the value of EAX and we can convert it into the hexadecimal, again pop and convert without changing its actual value. Okay, so the value which I enter here is, if this value is, for example, 19 and then 22, first of all is the 41 and then 00029. Actually there is no space between these two. I want to use the something like message 3 is byte, and we have 13, 10 and 0. So I want to print, before printing this one, std out is the message 3. Okay, so I just build. Okay, I just run this one. Value is 19 and 12, 31 and the 1f. So we have performed integer addition and also the addition, and so these two values are being considered as a for example, at the time of addition we have converted them into the in hexadecimal, or whatsoever you can call it. Those 31 is in, actually the total is in the decimal, but when we print it we are converting it to the hexadecimal. But how we can directly receive the hexadecimal values, that is the different story. We can do that one also. So hopefully in the future or the next few lectures we will use all these functions. So this is the I think the program, and I will just save it here. So now we are going to summarize what we learned here in our lecture. We have implemented all these IO instructions. We use the std in, std out, and so on. So std in and std out, this is their format. We also use the dw to a, or a to dw, or dw to hex, and so on. So we have used these different functions which are part of the MESM 32. We have used the invoke, and we have used all these three functions to convert the double word to ASCII, or from ASCII to double word, and so on. So in this one, dw to a, we have information in any register, double word information. We convert it into the ASCII, and we have some buffer area or a string where we just send this data, or sometimes we have input or the data inside the ASCII buffer, so we want to convert them it into the value, and sometimes we want to convert whatsoever is in the register or in the double word into the hexadecimal value, and this hexadecimal value will be ASCII hexadecimal value. So we have used this ASCII hexadecimal value to print out. Then we have seen these jump instructions for like the conditional jump instruction, jump z. We have used the jump e, jump above, jump below, jump greater than, and so on. So we have implemented, we have seen some examples, and we have tested these conditional jump instructions inside the assembly language. We have developed the logic, for example, if I want to print the series and so on, and we can directly print the same input, or we can convert if we get the receive value from the input, receive this value, and we want to convert into the integer and hexadecimal, perform addition, perform subtraction, and so on. So this is all inside in this lecture number 19, and hopefully inshallah in the next lecture number 20 we will discuss new topics inside the assembly and inside the computer organization. So till lecture number 20, Allah Hafiz.